Extracting geometry. This task shows how to perform an extract from elements. This may be especially useful when the generated element is composed of several non-conics or sub-elements. Using the extract capability, you can generate separate elements from each sub-element without deleting the initial element. So let us select the extract icon. We have point continuity, that extracts element will not have a hole. Tangent continuity, the extracted element will be created according to the tangency condition. Curvature continuity, the extracted element will be created according to the curvature conditions. And no propagation, only selected element will be created. So when we do that and select this, we can see that only this element will be selected. But for continuity point, everything will be selected. And for tangent continuity, only the tangency part will be selected for an element that we have selected. And click on OK. We can see that the extract element is added to the specification tree. When the result of the extract is not convex, that is during creation or addition due to naming ambiguity, you can now select the part to keep to solve the ambiguity. Rotating geometry, let us select the rotate icon and click on the element and select the axis along which we want to rotate. And as we increase the degree, we can see that the element is also rotating. This is edge direction, horizontal direction. Let us change it to vertical. You can see that the element will get rotating on the vertical axis. Like this. Or we can also select this axis. We can see that it gets rotated along the line, along z axis, along y axis, and along x axis. So this is how we use rotate. For using translate, let us click on the translate icon and select the element, and in the direction of x, let us increase the distance. We can see that the element is getting translated. Now if we select y, we can see that we have two elements, and along z, like this, depending on the distance. For symmetry, let us click on the symmetry icon, select the element and select the reference. You can see that we have got an element symmetric to the element selected. Select the plane. We can select vertical, it will be the same place. Select another plane, we get it in front. This is how we use symmetry. For scaling, let us select scaling. Select the element and let the reference plane be this. And when we increase the ratio, we can see it become double. Now it will become triple. If we change the plane element, you can see that it becomes like this. When we decrease the ratio, twice the element, thrice the element, 4 times the element. We can again change the plane and we get this is 4 times the element, 3 times the element, twice the element. Click on OK. This is how we scale the element. Now using affinity, let us select this element and the origin be this. Let us increase it to 2 and preview. We can see that it's increased in x-axis. Now if we increase the y-axis, the element will become like this, and increase in the z-axis will give an element like this. Click on OK. This is how we use transforming geometry by affinity. Transforming axis, let us select the axis to axis definition, select the element, create a reference element here and click on OK. Select the target, create axis right here. OK. Now we can see that the axis has got shifted from here to here. This is how we create axis to axis transforming elements. Now for extrapolating, this task shows how to extrapolate a curve. So let us select the boundary and extrapolate. Let us increase it. Let us keep it as 50 mm. Select preview. We can see that the curve has got extended a bit. And click on OK. We have extrapolated the curve. This is how we extrapolate curves.